Good. So we're doing an hour tonight?
Yeah.
Okay. You got a quiz coming up?
Yeah, tomorrow.
Okay.
I'm sending you pictures now.
All right. Kind of
Alright,
stuff.
the first one is in the process of sending.
All right. Do I need my calculator? Do I need to get it out?
Yeah, you might, because it's like graphing stuff.
Okay.
Oh, I typed your email wrong. Hold on.
David Cowan 1949 at gmail.com.
There we go. Alright.
Let me guess. We're doing factoring polynomials that are third degree or fourth degree?
Yeah, we're doing like pretty much the same things that we did on Tuesday.
Okay. All right. I got the first page.
That's the first page, and I've already done most of it, so we can just check it.
If the discriminant is a perfect square and the coefficients are integers, what must be true about the roots? The roots are real. If the discriminant is a perfect square, so the roots are real and rational. Okay. Given that the discriminant is negative, what must be true about the roots? They have to be imaginary. Okay. Sketch a graph of a quadratic with a leading negative coefficient and a negative discriminant.
Yeah, I didn't do these two.
Okay. What would that look like?
With a negative leading coefficient,
What does that mean?
that it's opening down.
Okay. And what about a negative discriminant?
That it'll be imaginary.
Which means what? In terms of
the graph.
Are there any x-intercepts?
No.
Which means the graph has to be like that.
Yeah.
It can't be like this. If it was the above one, it would have zeros, which means it would have real solutions. So when it's down below like that, it has no real solutions and it opens down because of the negative leading coefficients. Okay, how about 4? Sketch a graph of a quadratic with a positive leading coefficient and a perfect square discriminant.
It'll open up, and the numbers will be real, so it will have an intercept or intercepts.
Not quite. What do they mean by a perfect square discriminant? Like 25?
Yeah.
Okay.
Like doing all the math inside the discriminant.
Oh, I see. If it's perfect square, then it has to be rational. If it's not a perfect square, it has to be irrational. Okay.
Yeah.
All right. Match the equations with the appropriate graph. consider the vertex and or intercepts when making your selection. Make a table. Turkey? What does turkey stand for?
I have no idea.
Okay, let's look at this first one here. You say that that is I, x squared plus x minus 30, because that factors into x plus 6 and x minus 5, which makes the intercepts minus 6 and plus 5. There's the plus 5, but that one's minus 4. Did I do that right?
Yeah, I'm graphing it now.
X squared plus x minus 30. X squared plus x minus 30 graphs into x plus 6 and x minus 5, which means x equals minus 6, x equals 5. Let's see if we can see a function that goes right there. This one over here, number 7.
Yeah, that's 6. Yeah,
Goes
5's right for 5.
Goes through minus 6, goes through 5. I don't see any other one that does that.
All right, so E and I are switched.
Okay, so let's check 7 before. So you're saying 5 is E. So the solutions are minus 4 and plus 5. Okay, yeah, you're right. 5 and 7 are switched.
That's just me not reading my graph right.
Okay, let's look at 6. You've got L. What is that? What is that?
That's a G.
That's a G. So it opens down, and it's in standard format, which means our vertex is 5 minus 4. Right? In other words, G is in vertex format, where the vertex is that number, plus 5, and minus 4. That's K. So what has a vertex at plus 5 minus 4? Right there. Okay. That looks right. No, except that doesn't open down. Oh, yes it does. Excuse me. Sorry. Yeah. And it's a little wider than normal, which reflects the minus 2/3. Okay. So number 8, H, opens down, has a vertex at 5 minus 4 also, but it's skinnier than the other one. So the only way to distinguish H and G is the thickness of that parabola. And the minus 2 indicates a skinnier one as opposed to the fatter one, which is minus 2/3.
Is it the higher the number for the value of A, the skinnier the graph is?
Yes, the higher the absolute value. I hesitate to say higher the number because notice that minus 2/3 is actually a higher number than minus 2.
Yeah, I just noticed that.
On the number line. So it's the absolute value of that that determines whether it's skinny or fat. 1 is normal.
Okay.
Anything greater than 1 is skinnier than normal. Anything between 0 and 1 is fatter than normal. All right, number 9, you've got F. So that opens up, has a vertex at 4, minus 5. That looks right. 10A. That opens up, has a vertex at 5 minus 4. Different than that. Okay. And that looks normal. And 11. Let's see. You said it was C. It opens down, has a vertex, or has x-intercepts at plus 4 and minus 5. C. opens down, has intercepts at +5, -4. Oh, like that one. Okay. No. It has the intercept, not the vertex. So the intercepts are at +5, -4, and that one is. Okay, D opens up. Its intercepts are -4, +5. That looks right. And 13 is B. The intercepts are +4 and -5. Okay, so it looks like the only ones you missed was 5 and 7 need to be switched.
Yeah, that was just me reading the graph wrong.
Okay.
No, I haven't done any of these next 2 pages, so.
Okay. Okay. So what is the appropriate form for number 14? Vertex or intercept?
Mm-hmm.
Jackson, you there?
Yeah.
Okay, I wasn't sure if I lost the audio for a moment.
Yeah, I'm thinking,
It's not an easy question. Figuring
does
out
this
what
matter?
No, it really doesn't. The only thing that notice the difference between 14 and 15. 15 has the vertex labeled. So most likely 15 is the vertex format.
Okay.
On 14, the points that we can clearly see are integers are on the x-intercepts, so I would say 14 is intercept form. 16 is probably vertex form. In other words, notice that on 15 the vertex is clearly labeled, but the x-intercepts are not. They appear to be close to integers, but not quite. So, all right, let's look at 14. So 14, we're going to use the x-intercept notation. So what is it going to be?
Y equals A in parentheses. I'm still stuck on like how to solve these.
Okay, okay, if we look up here at the intercept format, it's A times x minus p times x minus q, and p and q are the intercepts. So what are the intercepts?
Does it matter which one's which?
No, it doesn't, because you have the associative property. So, you know, x minus p times x minus q is the same as x minus q times x minus p.
Okay.
So what's p?
We can just put p as 0.
Okay. What's q?
+7.
So it's x minus 7. Okay, so we get that far, and now notice that there is another point on that curve that is labeled. What are the dimensions, or what are the coordinates of that point?
1, -12.
So 1, -12 is on this curve. So, does that allow me to solve for A?
Yes, you plug those points in.
Okay, so I got minus 12 equals A times 1 minus 7, which is a minus 6.
So you just plug that 1 into wherever there's an x?
Yeah, when we have the equation of a quadratic and there is a point that is on that curve, that means that those coordinates for x and y have to fit whatever equation we come up with. It's like a point being on a straight line. It plugs into your linear equation. So
okay.
It has to fit whatever equation we come up with. And that allows us to solve for A. So what is A?
Negative 12 equals A. It'd be negative 6A, or negative 12 equals negative 6A, so A equals 2.
And now what is our specific equation for this particular quadratic?
Y equals 2, in parentheses x, close parentheses, parentheses x minus 7.
Right. In other words, we only use that point to solve for A. Then we go back and we use x and y in our regular equation. Now,
Okay.
is this a satisfactory final answer, or does she want you to multiply this out?
No, this is fine.
Okay. So we're going to do a...
Actually, let's turn that into standard form.
Okay. You sure? Because the question says...
just for practice.
Okay, for practice, all right.
Yeah.
Go ahead.
It'd be 2x, and then x squared minus 7x.
Okay, you need to distribute the 2.
Yeah. 2x and then negative 14.
Tell you what, I can see why this is a little confusing, so let's make it this. Same thing, right?
Yeah.
Now, it's easy to distribute now. Minus 14x. So that's standard format.
Okay.
There's no C. I mean, there is a C, but it's 0.
Now, would you recommend writing the 0 or just leaving it?
Leaving it like this.
Okay.
I've never, ever seen it written like that. Ever.
Okay.
Okay, let's look at 15.
So this 15 is going to be vertex form because we actually have the points labeled, right?
And it's the only exact, in other words, notice that if we tried to put it in intercept form, we would have to figure out what these numbers were. And it's not so clear that they go through whole numbers. Whereas this one, they've labeled, and it's an integer. If they hadn't labeled this, I'd be reluctant to say I knew what this point was. But since they labeled it, we know what it is. And that's the clue as to what format we want. So we want y equals a times x minus h squared plus k. And we know h and k. So what's the next step?
H and K.
H is the x coordinate of the vertex. K is the y coordinate of the vertex.
So it'd be y equals a in parentheses x. Would it be plus 4 or minus 4?
Minus 4.
So it's the opposite of that sign?
No, it's always x minus h. So, yeah, I guess it is. But h is positive 4. You see that? H is positive 4, but the standard format is x minus h.
So that minus sign is always there. So if that was a negative 4, those two negatives would cancel out and it'd be solved as a x plus 4?
Yep.
Okay.
What's the rest of it?
Plus 10.
Minus 10.
Minus 10.
In other words, k is minus 10, So if I plug in minus 10, I get plus a minus 10, which is minus 10. Okay?
Okay.
And there's another point on this curve that we could use. We could use this point over here where x is 0. It might be a little easier to solve the equation, but it's going to be harder to figure out what the exact value of y is there. Well, not really. We know it's actually 10, but they don't
Yeah, I was
like,
going to say it's...
but because it's symmetrical about 4. And it's 4 to the right, so it's 10, so 4 to the left would have to be 10 also. But let's use this point here because they've spelled it out. So what's my next step?
What, or no, 10 equals a in parentheses 8 minus 4 squared minus 10.
So 10 equals 16a. Add the 10 to the other side, right?
Yeah.
And a equals 5/4. So my specific equation in vertex format is what?
Y equals 5/4 in parentheses x minus 4 squared minus 10.
Good. That's the process on all of these, is you solve for a as the first step. Okay? Vertex format or x-intercept? I'm sorry, what?
Can we convert that into standard form?
Sure. What did I do? Erase it? Y equals 5/4 x minus 4 minus 10. Go ahead.
Would that x minus 4 turn into 16x?
Well, I forgot to put the squared in. So the first thing you need to do is square x minus 4.
So is that really a negative 4x squared, or are you squaring each individual number?
It's x minus 4 quantity squared, but the square does not apply to the 5/4. So I need to square it before I can distribute the 5/4.
Okay, so it'd turn into x squared plus 16?
No. Use your a minus b squared. What does that turn into? That's a real important thing for you to memorize. A minus b squared is equal to a squared minus 2ab plus b squared. And we're doing x minus 4 squared. Most people tend to forget that middle term. Always remember there's a middle term there.
That would turn into negative 8x plus 16.
Okay. And then I still have my minus 10. So what's the next step?
Move the 10 over, or distribute.
Just distribute, because notice that standard form, if you look at the top here, is y equals ax squared plus bx plus c. So I want to leave y all by itself. Now distribute.
5/4 x squared oh wait, hold on. Minus 10x, and then plus 20.
Minus 10. Right? We can't forget the minus 10. Okay. And simplify that. In other words, the only putting those two together is all you need to do.
Okay.
So that's plus 10.
Okay.
That's standard form.
So it's really just a bunch of distributing to get it in the standard form.
Absolutely. All right. 17. Vertex or x-intercept mode or format?
This one is going to be intercept form.
Okay. Only because they've labeled it, because that would have been a hard one to read otherwise. So they've labeled 3 points on this thing, so that's pretty clear. So what's the first part that I'm going to write?
It is 4 -8 is the vertex.
Hold on. We're not using vertex. We're using intercept. So what's the general format for intercept form?
A in parentheses x minus p times x minus q.
What are p and q in this case?
0.
They're the intercepts.
Yeah.
The x part of the intercepts. Not the y part, the x part. So one intercept is minus 4.5.
Okay.
That turns into x plus 4.5. What's the other intercept? Notice they're both negative in the general format.
Wait, we were looking at different problems. I'm looking at 6. I think you skipped. Did you skip 16?
No, we did 16. I moved on to 17.
Okay.
We did 16. I believe we did 16. Maybe we didn't. No, you're
Yeah,
right.
I don't think we,
No,
yeah,
you're
I don't think
absolutely
we
right.
did.
My apologies. My apologies. 16, we're going to use vertex format. We're not going to use x-intercept format, right?
Yeah, we don't have the. Yeah, we don't.
We
have
don't
the,
have any. We don't have any x-intercepts, so we don't really have much of a choice. We have to use vertex. Sorry. What's the vertex? They don't label it, but we can read it pretty easily.
4 -8.
So what should I write?
Y equals a x minus 4 squared and then minus 8.
Okay. They give us a point right there. What are the coordinates of that point?
2 -10.
So now what?
-10 equals a in parentheses 2 minus 4 squared minus 8.
Okay, next line.
2 minus 4 squared is 4.
Okay.
4.
So read the next line. So minus 10 equals what?
Hold on. Oh.
What's 2 minus 4 squared equal to?
Yeah,
What's 2 minus
sorry.
4?
-2.
What's negative 2 squared?
4.
Okay, so we got 4a minus 8. Move the 8 to the other side. A equals negative 1/2. So the specific equation is what?
Y equals 1/2
Negative
x
1 half.
or negative 1/2, yeah. X minus 4 squared minus 8.
Okay, you want to put this in standard format?
Yeah, it's going to be, okay, X. It's going to be Y equals,
Do it in steps. Don't try to do the whole thing in one step. In other words,
yeah, I'm doing it out right now.
square the x minus 4 first.
The x minus 4 squared is x squared minus 8x plus 16.
Now distribute.
Negative 1/2 x squared plus 4x
Correct?
minus 8 equals, or not equals, minus 8, yeah.
Don't forget that last one. So now what's the final quadratic and standard form?
Y equals negative 1/2 x squared plus 4x minus 16.
All right. And double check. That's negative. That opens down. That's good. We wouldn't want to come up with a positive A. It means we would have done something wrong. All right. Now we can look at 17. Okay, what
So
are we going to...
17, we're going to want to use intercept form.
Right, because that's what we're looking at is the intercepts. Okay, so intercept form is this. Okay.
We'll have P be negative 4.5 and Q be 3.
So what's the
So
next
A,
line?
in parentheses, X minus 4.4, minus negative 4.5.
So what's the next line?
X plus 4.5, and then X minus 3.
Okay. And the point they give us is minus 5 minus 24.
So negative 24 equals A, in parentheses, negative 5 plus 4.5, and then from negative 5 minus 3.
Now, notice that any point on this parabola has to fit this equation. So if they'd have given me a point up here, I could have plugged it in. If they'd have given me a point over there, it does not matter where it's at. As long as it's a point on that curve, I can plug it in.
Okay.
Okay. So what do we have here?
So negative 24 equals A, or A and then negative 0.5, and then negative 8. So is that negative 4? Wait.
Oh, that's right.
Yeah, so that turned into positive 4. So negative 24 equals 4A.
Okay.
And then divide both sides by 4, A equals negative 6, yeah.
Okay. And again, good thing we have a negative sign because we see that it opens down. So what's our final equation in intercept mode?
Y equals negative 6, X plus 4.5, and then X minus 3.
All right. You want to put that in standard form?
Yeah. Y equals,
I always would advise doing those two first.
okay.
Keeps your numbers small when you're dealing with the quadratic.
So that would turn into negative 6x squared plus 1.5x, and then negative 13.5. And then that turns into negative 6x squared minus 9x plus 81.
Good. Okay. 18. What are we going to use here?
18, we're going to use the vertex form.
Yeah, it actually looks like we could use either one, because the intercept looks to be clearly at -5 and +1. But the points they've given us are the vertex, in other words, this dot here, and 1 point. So let's use the vertex format.
Y equals a x minus h squared plus 8. K. Yeah, K.
Okay. What's h and k? So what's the equation?
It's going to be y equals a x plus 2 squared, and then minus 3.
Which point are we going to plug in?
Do we have one?
Over here. In other words, look for their big dots.
Okay.
We only needed one big dot for the vertex, and we only need one other dot for a point on that parabola.
So in order to solve these, you only need 2 points.
No?
Or,
if one of them is a vertex, you only need one more point. But if one of them isn't a vertex, you need 3 points. 3 points define a parabola.
Okay.
Okay, but if one of them happens to be the vertex, then that gives you h and k. And the only thing you need to solve for is a, and one other point will solve for a.
Okay. So it's -5, 0. So 0 equals a 5 or -5 plus 2 squared minus 3. And then 9a minus 3. 3 equals 9a. And then a equals 1/3. So that turns into y equals 1/3 x plus, x plus 2 squared minus 3.
And then distribute or expand.
X squared plus 4x plus 4 minus 3.
And now distribute.
That turns into 1/3 x squared 4/3 x plus 4/3 minus 3, and then the final one is y equals 1/3 x squared plus 4/3 x minus 5/3.
Now, is it okay to have fractions? like this?
I think it is,
In some
but
cases,
it would
if
probably.
they say standard format, you would want to maybe.
Let's just get rid of the fraction.
Well, here's the problem: is that it's not the same function if I multiply both sides by 3. If I'm trying to solve for the zeros, and I can say that y is 0, then I can do that. But this function that you're looking at here is not the same as this function. It just happens to have the same zeros.
Okay.
Okay? So this really is the function that we came up with. You don't have answers on any of these?
I do not. I'm getting them either tomorrow or Monday.
Well, plus notice that they did not ask for any of these in standard format. The direction.
Yeah, it's just for practice.
Okay, that's fine. I am a little unsure as to whether standard format includes the fractions or this. In other words, I'm not 100% sure whether this would be standard format or that would be standard format. It seems to me that I seem to remember standard format not having fractions, but I'm not positive.
Yeah, that's how I was taught.
You were? So you would say this is probably standard format.
Yeah, but I'm not sure what she wants us to do, like, in this particular setting. I know when we were actually, like, solving, like, other equations, she wanted us to not have fractions.
Okay. Okay. Well, it's hard to tell here because she hasn't really asked for this to be in standard format. So that's something you might want to check, whether standard format allows fractions. Seems to me that it does not, but I'm not 100% sure on that. And I'm not also, if it does not, I'm not real comfortable with just multiplying that by 3 to get rid of the fractions. It seems to me that that's a different function. It's not the same function.
Okay.
So you might ask her about 18 on what it would look like in standard format. So how about 19? Again, we see only 2 points. So
vertex form.
So it's got to be vertex form. So what is it?
Y equals A. X. That's probably X plus or X minus -5. So X plus 5 squared plus 18.
And the point looks like -518.
Oh wait, hold on. That's the point. Yeah.
Sorry, I lost my train of thought there for a moment. What is the point?
It looks like 0, 13.
Okay.
So that turns into 13 equals A, 5 squared plus 18. So 25A plus 18, or just, yeah, -5. So divide that, A equals -1/5. So Y equals -1/5 X plus 5 squared plus 18. Alright, and then in standard format, that would be Y equals -1/5 X squared plus 10X plus 25. Plus 18. And then that would be -1/5 X squared minus 2X minus 5 plus 18. That turns into Y equals -1/5 X squared minus 2x plus 13.
Okay, now you can see that if I were to multiply every term by minus 5, I would get rid of the fraction, but it's a different function.
Yeah.
Because I would automatically turn it from facing down to facing up. That can't be right. So standard format has to be this. I cannot multiply that by 5 or minus 5. It's a different function. Okay? The zeros will be the same. In other words, I could multiply this by minus 5, and these two zeros would be the same between this function and the function I would end up with, because it doesn't affect the zeros, but it does affect the function. It affects where the vertex is, whether it opens up or down, all of that good stuff. So I think standard format, you're going to have to leave it like that.
Yeah.
That was 19, right? Yeah.
Yeah.
So here they want it in standard form, intercept form, and vertex form. Okay.
Let's just do one of these and then move on to the next page, because the next page is harder stuff.
Okay. What are we going to do here? We have 3 points. We don't have the vertex. We don't have the x-intercepts. I mean, it looks like the x-intercepts are 7 and minus 1, but that's not the way they want us to do it.
So we have to find them in all 3 forms.
So if we let this be the standard format, how can we solve for A, B, and C? We need 3. We're going to need 3 equations, right?
Yeah.
And 3 unknowns. Well, give me 1 equation.
Do you just use the x coordinates for each point, or?
Use the points for the y and the x value.
Alright, so first one you could do, is that 20?
Yeah.
Yeah. 27 equals a, in parentheses, negative 2 squared. Plus bx
plus b times minus 2
plus c.
Plus c. Okay, so let's simplify that.
27 equals 4a minus 2b plus c.
There's your equation number 1. Equation number 2.
Negative 45 equals a, in parentheses, 2 squared plus b, 2 plus c.
So that equation number 2 is negative
45 equals 4a plus 2b plus c.
And finally, we need a third equation.
Negative 36 equals a, in parentheses, 5 squared plus 5b plus c.
So there's our third equation. Now, let's talk about solving 3 equations and 3 unknowns. She says use regression. not exactly sure what she means by using regression. This is the only way I know how to do it, is to set up 3 equations and 3 unknowns. Just the technique.
Isn't there a function on your calculator that solves for 3 equations?
Ah, yes, there is.
Is it the matrix? Is that what it's called?
Well, I don't know. Let me look at my calculator and see here. There's definitely a linear or a quadratic regression. So, what do I need? I need a table. So, let's see. Go to Home. Do you have your calculator?
Yeah.
Let's go through this together. Tab down to the table, the middle icon at the bottom, and go up to the top and label A, B, and C. A is the first one. Tab right, put a B. Tab right, put a C.
All right.
Now, go down to row 1 and put in our 3 A values. Hold on, let me think about this for a moment. Let's do this different. Let's go up to the top again and make the first thing X, tab over, make the second thing Y, tab over and delete that, C.
All right.
Now under the X, let's put the 3 X points. -2 and use the minus that's in the parentheses.
Okay.
Tab over to the Y value, which is 27. The second X is +2, and the Y is -45. Again, use the proper minus sign. And the third row is 5 -36. And make sure that's all you have. And make sure your cursor or the cell you're on is outside of those first 2 columns.
All right.
Now let's see if we can do a quadratic regression of that. Menu, statistics, stat tests. Nope. Maybe. I see linear regression. I see multiple regression. Wow. Let's try stat calculations.
Go to stat calculations. It's number 3 on mine, I think.
Okay. I went to stat calculations and I see quadratic regression as number 6 on mine. So pick quadratic regression. And then in that first block, hit the mouse center point.
Okay.
And go down until you find X. Hit it.
Okay.
On the Y list, tap down to the Y list, hit the mouse center point again, and go down until you find Y. Choose it. Now you can tab all the way down to the OK and hit Enter. And there's your quadratic equation. Read it for me. So Y equals what?
Is that on mine? It has in row 1, column D. It says quadratic regression. Row 2, it says the A and then X and all that. Row 3, it has number 3 Row 4 is negative 18, 5 is negative 21.
Okay, notice right above the 3 it says ax squared plus bx plus c. So the a, b, and c it's giving you are those numbers. So what is our final quadratic equation?
So would that be 3a squared?
3x squared.
Or no, 3x squared, excuse me.
Mm-hmm.
Minus 18x minus 21.
Perfect. Much easier way to do it than the way I was going to do it. I would have gotten that doing it this method, but that method was not using regression to find it. Okay. Let's see. We only got a few minutes more. Do we need to look at another page? We probably don't want to do 2122. You know how to do these, right? Now, notice that it wanted it in all 3 formats. That's not going to be quite as easy. In other words, how do you go from standard format to vertex format?
Do you have to unfactor or factor?
No, if you factored it, you would get closer to intercept format. First of all, can I factor anything out of that?
I don't think so, no.
3. Right?
Actually, yeah, you can. Yeah.
Okay, now can we factor that? If we can factor that, we will be in intercept format already. Done.
I don't think that factors.
We're looking for factors of 7 that subtract to 6. Okay? So there's intercept format. Getting it into vertex format requires that we complete the square. Because vertex format is this.
Yeah.
Okay, so we have to complete the square using this part of it. So let's do that. In fact, let's finish this problem up and we'll be done. But this is an important part here. You need to know how to get this into vertex format. So my plan is to complete the square. Okay? So let's write it like this. Leave room. Put the minus 21 out there. Now what's the next thing I need to do to complete the square of the inside in the parentheses?
Is it add C?
First, get rid of the coefficient of the x squared term by factoring that 3 out.
Okay.
Have not changed the problem at all. Now you have to add that third term. What is that third term going to be? Take half of this and square it.
9.
How much have I added to the right side of the equation when I write that 9 in there?
9.
I've added 3 times 9.
Okay. Oh, yeah, okay.
So I've added 27. So I have to subtract 27 from the same side of the equation to balance it out.
Okay.
Now I'm in a position to write it in vertex format. What's this? How can I write that?
X, would it be plus 6? Or minus 6?
Minus 6. Whatever half of this was is what you want to put in there.
Alright.
In other words, when we went through completing the square, we took half of 6. That was 3. So it's going to be x minus 3. Minus 48. There you have it.
Wait, where'd you get 48?
I had minus 21 and minus 27.
Oh, yeah, okay.
Okay? So our vertex should be at 3, comma, minus 48, is it?
Yeah.
Looks like it. Looks like that's exactly where it's at. Okay, so when you go to vertex format from standard format, you have to complete the square. That's the only way to do it. If you're going from standard format to x-intercept format, you try to factor it as much as you can. This one factored nicely. So we were able to put it in intercept format also rather easily.
What happens if it doesn't factor?
It always is going to factor using the quadratic formula. Let's go back to this where it was, whatever it was. Make that a 20 instead of a 21. It's not going to factor nicely. You'd have to use the quadratic formula. So your final intercept format might look something like this. Y equals 3 times x minus root 5 times x minus root 7 over 2. In other words, when you use the quadratic formula to solve for the zeros, they could be irrational. No problem. Still works. They don't have to be rational. Okay, so you know how to go from standard format to x-intercept format and to vertex format. It's not a particular easy thing to do, unless it's nice. If it has nice intercepts, obviously this one's going to factor nicely. That's going to factor into x plus 4 times x minus 8.
Okay.
Okay, but we're going to find this with linear or with regression. In other words, you're going to enter the table just like we did and do stat analysis, do quadratic regression. It's going to give you an A, a B, and a C.
Okay.
Okay, let me just look at your next page and see if there's anything that is new that we haven't talked about. Are any of these going to give you problems? 23 through 28. I don't see why any of those would give you any problems at all.
Let's go over 25 real quick.
Okay. That's x squared minus root 2x. Don't let them confuse you because they switched it around. How do I solve that?
Would you use a quadratic formula?
Yes. Go ahead.
It turned into square root 2 plus or minus the square root of 2. If you square, yeah, that turned into 2, wouldn't it?
It does. Mm-hmm.
Minus 4 in parentheses 1 and negative 1 all over 2.
And So that gives us square root of 2 plus or minus square root of 6 over 2. Now, the question is that in final format? I can change square root of 6 into square root of 2 times square root of 3. Not sure that helps any. Guess I could then factor out a square root of 2 from the top, leaving that. I don't think that's a prettier answer myself. I kind of like going with this right here.
All right.
In fact, I've seen this problem multiple times, and this is the answer that you see in the books, not the bottom.
Okay.
All right, so the only thing hard about that confused you was the fact that they switched the x and the root 2. If they'd have put the root 2 in front of the x, you would have recognized it as just a normal quadratic that you got to use the quadratic formula to solve.
Okay.
Now, the only ones you don't have to use the quadratic formula are like 26. You see why you don't have to?
Because you can take the square root of both sides?
Yes. In other words, I'm going to end up with x plus 3 quantity squared equals 7. What's the next step?
Wait.
In other words, first thing I did was divide both sides by 5.
Oh, yeah. Okay. Oh, okay.
Okay, now I can take, if I had tried to take the square root of both sides before that, I would have had a very complicated square root of 5 to deal with.
Yeah.
Okay, now what?
Turn into x plus 3 equals square root of 7.
No.
Or,
what do you have to do every time you take the square root of both sides of an equation?
plus or minus.
There you go. So now, what's the final answer?
X equals plus or minus 4.
Well, let's do it in 2 steps. We have minus 3 plus or minus 7. Now let's figure out what both answers are. One answer is x equal minus 3 plus 7, which is 4. The other answer equals minus 3 minus 7, which is minus 10.
Okay.
Okay?
All right.
And if you're going to solve these problems without using the quadratic formula, you better remember that plus or minus. Because solving them by taking the square root of both sides requires you to put that plus or minus down there, or you're going to not have one of the solutions. If we were to have expanded this first and then tried to factor it, you would have gotten plus 4 and minus 10 without having to know to use the plus and minus. So if you're going to take that shortcut, make sure you use that plus and minus.
Okay.
Same thing with 23. We don't need to use the quadratic on that. Just need to get x squared equals some number and then take the square root of both sides, and it's plus or minus.
Okay.
27 looks like a standard quadratic. You might be able to factor it, you might not. 28 looks like a standard quadratic. Minimums and maximum values for parabolas are what?
Yeah.
Where do you find the minimum and maximum values?
It has a minimum value if it opens up and a maximum if it opens down.
But where is it located?
Oh, the vertex.
Okay, it's the y-coordinate of the vertex, not the x, the y-coordinate. So you have to use minus b over 2a, perhaps, or, depending on what form it's in, but somehow you have to find the y value of the vertex.
Okay.
Okay? All right.
All right.
This one, number 34, use substitution. That is a quadratic. It just doesn't look like one. You see why it's a quadratic? The middle term is square root of y, and the first term is that middle term squared. So if I let u equal square root of y, this thing will solve as a quadratic.
Square root of u equal y?
No, it's never square root of u. It's always u equals something. So u is the middle term. U is equal to the square root of y.
Okay.
That would make this term u squared. So I would have u squared minus 4u minus 5. That factors easily, and then you can solve for u, and then you can solve for y.
All right.
Same thing with this one over here. You want to use u substitution. Same thing with this one here. U substitution. What's u equal to on 33?
33.
We're going to use u substitution. What's the u going to be?
2y plus 1.
Over?
Y.
If you didn't make it over y, you would not have a pleasant looking quadratic. You would have a bunch of u's and still y's. So you have to make it that middle term. That's what your u is the middle term. That makes this thing u squared. So we would have u squared minus u minus 6 equals 0.
Okay.
Okay?
All right.
All right, Jackson. You have a good evening, and I hope you do good on the test. I feel like you should. I know you're getting this stuff. You just need to be confident enough of it that you know it, that when you go in that test, you don't have those moments. And that's all about confidence. It really is. It's knowing that you know how to do it, not wondering whether you know how to do it or not.
Okay.
All right, let's see. We have another one for this weekend. Do you still want that one, or are you not going to need it because of the...
Yeah, I'm not going to need it.
You're not going to need it? Okay, let me just pull it up here. And so you're not going to need anything until after the holidays, right?
Yeah.
So I've got this one on Saturday. I will cancel. And let me just look next week. I don't have you down. I've got you next Saturday. You're not going to want that one either. I'll cancel that one. And this one Tuesday night. Okay. Jackson, have a good Thanksgiving. I will talk to you the week after Thanksgiving. Let's see. Do we have a standard one for that week? I don't think I have one in the week that's standard. Oh, yes, I do. I have it on Tuesday night at 7:30. Is that okay?
Yeah.
I will talk to you a week from this coming Tuesday, 7:30.
All right.
All right.
Thank you.
Happy
Bye.
Thanksgiving. Bye-bye.